Section 7.7, the determinant of a square matrix. The determinant of matrix A, which is given by those four entries, A1, B1, A2, B2, is given by DET of A. That's the abbreviation you will see on the calculator that is read as determinant of A. That's one way that you can express that. A second way can be writing matrix A, or what represents matrix A, the letter A, inside what looks like absolute value brackets, but this would be read as determinant of A as well. Or you can take and just rewrite the matrix, but rewrite it without the brackets. Notice just a slight difference. If it is a matrix you are talking about, it is in closed brackets like we see up here. If it is the determinant of that matrix you are interested in, then there are no brackets, and you simply write straight lines on each side of it. There is a difference between those two things, so make sure you are expressing them correctly. To evaluate the determinant of a 2 by 2 matrix, all you do is you multiply down this diagonal, so A1 times B2, and you subtract the diagonal coming back, A2 times B1. Only square matrices have determinants. So if it is not a square matrix, there is no determinant to be evaluated. Example 1 here, find the determinant of each matrix. To find the determinant of matrix A here, I multiply down this first diagonal, 2 times 2. Always subtract the diagonal coming back. That product is -3 times 1. So we get 4 minus a -3, which is 7. Letter B, multiply down the diagonal, 2 times 2 minus 4 times 1. We get 4 minus 4, which is 0. So the value of the determinant would be 0. Finally, matrix C, if I want to find the determinant, 3 times 4 minus 3 halves times 2. We get 12 minus 3, which is 9. So for a 2 by 2 determinant, simply multiply down the diagonal from left to right, subtract the product coming back from right to left. Probably quicker to do it by hand than plug into the calculator. We'll look at the calculator here for a larger than 2 by 2 coming up. Find the determinant of a matrix by minors and cofactors, then by using diagonals. There are obviously two different methods that we're going to talk about here. We're going to talk about minors and cofactors, which you will have to be able to use, and we are going to talk about diagonals. Diagonals only work for 3 by 3 matrices. Okay, so if you get into a 4 by 4 matrix, you cannot use the diagonal method. You have to use minors and cofactors. We're going to start here with minors and cofactors. The one thing that you need to remember is that if you're evaluating by minors and cofactors, always pick the row or column with the most zeros. And you'll see why when we go through the process, but that's going to be your starting point every time. Look for a row or a column that has the most zeros. In this case, row 1 has a 0, row 3 has a 0, column 1 has a 0, column 2 has a 0. So any one of those 4 would be fine to select. I'm going to pick row 1 to begin with here. I'm going to lightly put a dotted line through row 1 so I know that that's the row that I'm working with. This first method we're using is the minors and cofactors method. Make sure you know the difference by name, because if it tells you on a quiz or a test, evaluate this determinant by minors and cofactors, and you use the diagonal method, you're not going to get the points. So make sure you know the names and what each one entails. So now, each of these values in row 1, 0, 2, and 1, are going to become the coefficients on 2 by 2 determinants. One thing you have to remember, and this is the most important thing with minors and cofactors, our first entry is an addition, and then signs are going to alternate between addition and subtraction for the rest of the way. Same way going down column 1. Row 1, column 1 is always addition. Then it goes subtraction, addition, subtraction, and so on. Row 2 alternates so that the same sign pattern carries throughout the entire matrix. So in this case, because I started with row 1, column 1, when I go to evaluate this, it's going to be addition, subtraction, then addition. So I have an addition to begin with. We don't need to write an addition sign out front. That's just like a positive. My first value in the row was 0. What we do then is, since 0 is in row 1's already crossed out, it's also in column 1. So I'm going to lightly cross that out. The 4 values I'm left with are -1, 2, 0, and 1. That's my 2 by 2 determinant that I'm going to multiply that 0 by. You should be able to see right away why we want to pick the row or column with the most zeros, because it doesn't matter now what this determinant is, because 0 times anything is going to be 0. So that's going to make evaluating just a little bit easier. Now as I go across this row, I know I go addition, subtraction, so this is going to be a subtraction. Second value in the row is 2. So now I am working with that 2, and if I look at that, 2, cross out the column that it's in, the 2 by 2 determinant I'm left with is 3, 2, 4, 1. Next one is going to be an addition. Value is 1, 2 by 2 determinant. I'm now using the 1, which is in column 3. That row's already crossed out. Cross out that column. The 2 by 2 determinant I'm left with is 3, -1, 4, and 0. And now we just need to evaluate this. So I have 0 times, doesn't matter, but if we evaluate this, we get -1 minus 0, minus 2 times 3 minus 8 is -5, plus 1 times 0 minus a -4 is 4. We end up with 10 plus 4, which is 14. So the value of that determinant is 14. Going to pick a second. Before we look at diagonals, I'm going to do this a second way with minors and cofactors, just so you can see it a second time, and also to show you that it doesn't matter what row or what column we pick. Okay, so going back here, picking a different one, I'm going to start this time, and I'm going to pick column 2 so that you see it with a column. So I'm going to lightly cross out that column. I know that the values here, here, and here that I'm going to use are 2, -1, and 0 now. But this is where you need to be careful. Row 1, column 2 starts with a negative. So I'm going to have a minus out front, 2 times our 2 by 2 determinant. Cross out row 1. Since the 2 is in row 1, our 2 by 2 determinant we're left with is 3, 2, 4, 1. Alternate. Since we started with subtraction, it's now going to be addition. Our value is -1 in that second position. Our 2 by 2 determinant. Now we cross out row 2 is 0, 1, 4, 1. Subtraction. 0 times. Since it's 0 times, it doesn't really matter what it is. But if we just carry this through so we can see what we're doing here, crossing out now row 3, we're left with 0, 1, 3, and 2. Simplify. We get -2 times -5 plus -1 times -4 minus 0. 10 plus 4 is 14. We see we get the same answer as we got here. So it doesn't matter the row you pick, doesn't matter the column you pick. You can see that the more zeros that you have, the easier the evaluation is going to be. So pick the row or column with the most zeros. That's minors and cofactors. If we were going to evaluate by diagonals, take the original 3 by 3 matrix, write it as a determinant. So we have 0, 2, 1, 3, -1, 2, 4, 0, 1. There would be our original 3 by 3 determinant. You're going to take and recopy the first two columns to the right. So 0, 3, 4, 2, -1, 0. Now, this is similar to what we did with 2 by 2 determinants, okay, where you multiply down diagonals. We're going to do the same thing here, but we have more diagonals now because it's a 3 by 3. There are going to be 3 diagonals in both directions we're going to look at. I'm going to multiply down this diagonal, down that diagonal, and down that diagonal. So down the first one, there's a 0. That's nice. 0 times anything is 0. Plus, we're adding up the product of these 3 diagonals. 2 times 2 times 4 is 16. Plus, our third diagonal again contains a 0, which is nice. Now, we're going to subtract the 3 diagonals coming back from right to left. So I'm looking at that diagonal, and that diagonal. And I'm going to subtract those coming back that direction. So the first one, -6. Second one, -0. Third one, minus a -4. 16 minus 6 is 10. 10 minus a -4 becomes 10 plus 4, which is 14. Again, you see we get the same value. So it doesn't matter the method you use. Doesn't matter the row or column that you pick in minors and cofactors. You should get the same solution if you do things correctly. Again, make sure you know that this is the diagonal method and how to use it. That the first two we did were minors and cofactors, and you know how to evaluate those. Make sure you know them by name. Let's look at this on the calculator. Okay, enter in this matrix. So go into your matrix menu, edit 3 by 3 matrix, put it in 0, 2, 1, 3, -1, 2, 4, 0, 1. Exit out of there. Back into your matrix menu. Go over to math. Determinant is the first command under math. Determinant of matrix A. Hit enter, and there's our value. We can do it very quickly on the calculator as well. Last one here. Find the determinant of each triangular matrix. If you look at these two matrices, it should be clear why they are called triangular matrices. First one has a triangle of zeros above the main diagonal. Second one has a triangle of zeros below the main diagonal. If you have that situation where you have all zeros above or below the main diagonal, that is called a triangular matrix. When we have a triangular matrix, it is very easy to find the determinant. Simply multiply straight down that main diagonal. 2 times -2 is -4. -4 times 3 is -12. There's the value of the determinant. Same thing here, triangular matrix. Multiply straight down the diagonal. -3 times 2 is -6. -6 times -8 is 48.